lesson 9.1 notes. We're going to do a quick review on a few things when we talk about trigonometry. So first I want to do is let's just graph this from y equals sine x over negative 4 pi to 4 pi. So that's our domain. So one end will be negative 4 pi and the other one will be 4 pi. So what I want to do is remind ourselves with the parent function, a little bit about the parent function, just so that we can really graph. So if I think about the parent function of this graph, we know that it's the parent, let me write it, parent function and the period will be 2 pi. The range, we're going to go from negative 1 to 1. And when we do this, we're counting by pi over 2. So, and this is our domain here. This is your domain. So what we're going to do is we're going to graph this. I'm going to change this a little. So I'm going to plot this. If I'm going by pi over 2, counting by pi over 2, I'm going to put my 1 way up here and my negative 1 down here. Give myself plenty of room. So I'll go pi over 2. What I'm going to do is I'm just going to do it to 2 pi first for the period, just so we can remember what the parent function looks like before we graph it all the way to the full domain that they would like for us to do. Okay, so that is where it's asking us to graph. So if you remember, when you start to do this, you're going to start at the midline and go up to the maximum, midline again, minimum back to the, minimum back to the midline. So we'll graph this nice and smooth best we can. And that is 1 period of 2 pi. That's the length is 2 pi, and it's 1 period. So what I'm going to do is I'm going to finish graphing all this out from negative 2 pi to pi. So do that, and negative 4 pi to 4 pi, and see how it looks. Okay, so here we have a great graph from negative 4 pi to 4 pi, and I kind of graphed the each of the periods in different colors, so you can see there are 4 periods here. Okay, and we're going to look at really quick review with the unit circle real quick before we start talking about all this, but on parts of it. So I'm going to go back and forth that. But when we graph it, then we try to look at this thing. I want you to remember your trig charts and stuff that we did at the very beginning of this trigonometry semester. So if you think about that, that'll help us to do the rest of this lesson. So the first thing we'll look at is let's just answer these questions, and then we'll go back and look at what we need the trig chart for. So looking at only at 0 to 2 pi, where does sine x equal 1? And remember what we're talking about here. We are talking about an angle. Okay, remember this is the domain. And then when they're asking you about this, they want to know looking for an angle. So looking for an angle. So remember, this is in radians. We're measuring in radians instead of degrees. So that's talking about the angles. So if I go and I look at my graph up here, where does it look like sine x equals 1? Well, it looks like it right here. Right here. Okay. And then, so that's at pi. And I'm just looking between 0 and 2 pi first. That's what they want. So now I just think about that. So that's going to be at right here at pi over 2. So that's the angle. Okay, pi over 2, 90 degrees. Thinking about the unit circle. All right, now where does it, now if I'm just looking from this domain, from 4 pi to 2 pi, around 2 pi to 4 pi, this is again a domain. Where does that look at? where it is the same kind of question. So I'm looking from here to here only. And where do we see it to look like that we're at 1, which is right here at this point, which is 5 pi over 2. So it's going to be at 5 pi over 2. Okay. Now, when we look at this, we want to know the third question is, what is the difference between the points from A and B? So if you look between these two, and I'm talking about here at pi over 2, because I want to know between this one and this one, what is this distance? Okay, what's the difference between the points, the distance between them? Well, if you take 5 pi over 2 and minus pi over 2, then you're going to get 2 pi. They are 2 pi apart. Okay, so now it says the next one is solution to sine x equals 1 over 0 to 2 pi is x. This is when x equals pi over 2. Then we want to know the solution to the sine or x equals 1. So we want to know exactly what that is. Between 0 and 4 pi, okay, is going to be pi over 2. And what we had up there was 5 pi over 2. Both of those are going to be the answer. So the solution to, like, again, this is a domain, this is a domain. The solution to sine x equals 1 with no domain restriction. What are those x values? What are those angles? Okay. So if you think about it, over here, look, here's another one. Here's another one. Okay, those are all ones. And again, it's just any of them. So it's going to be every two pi starting at pi over 2. Now the math speak, what to say, or the math general form for this. Okay, so what we would say would be, so it would be at pi over 2, so that's where it starts, plus k times 2 pi. So that's at every 2 pi because it's a period. And k is the number of periods. That's just a general form. Up here we just say every 2 pi starting at pi over 2. That's when we're going to see sine x equals 1. Okay, if you have your unit circle, or you can look at what I have, or I want you to look at this. I want to review a few things because we are using this to help us with this next unit. And we have to kind of remember a few things about our unit circle and these angles that we use. So we kind of want to make sure that we look at this first quadrant for sure. What we're going to really look at too is, remember, we talk about reference angles and so forth. Our first quadrant, those are our reference angles. So when we talk about pi over 6, that's 30 degrees. We're saying that if I want the sine of that value, if I want a sine of 30 degrees, I know it's going to be this x value is going to be 1/2. And I know that if I wanted the cosine of 30 degrees, this is the square root of 3 over 2. Remember that it's cosine, comma, sine, or x is associated with cosine, and y is associated with sine. And tangent, remember, is sine over cosine. So when we look at what we're doing with these, we're going to kind of pay attention to what we get. Remember, 45 is really our easiest, pi over 4. Both sine and cosine are the same. And this is where tangent equals 1 because it's sine over cosine. Again, 60 degrees and so forth. So you remember these three reference angles here that we use all the time. Now remember, if you go into the next quadrant, each of these quadrants, you'll remember that you can easily get those values in radians without having to know exactly where they're at. Remember, these square root of 3 over 2 and 1/2 will be the same. So if you have a reference of 30 degrees of pi, or let's just do radians because that's what we're talking about most of the time. Pi over 6. Well, my reference angle over here for pi over 6 is at 150 degrees. I know at 5 pi over 6. And so that means these two values will still be, they'll look the same. The only difference will be what quadrant you're in. And we know if we're graphing this way and you're graphing a point, negative x is negative, y is positive. We're graphing down here, a point down here in the in this area, negative quadrant 3, it's a negative. Both values are negative when you're graphing. So what I want to do really quick too is kind of refresh our memory on how we can easily get these angles over here without having to worry about, oh, I got to remember everything in order and so forth. Just remember that when you are in the first quadrant, all of them are the same. That's your reference angle. You don't have to worry about it. When you are in the second quadrant, you're going to take the denominator. Write this down. You're going to take the denominator and minus 1 will give you the numerator. So if I wanted to know what's in quadrant 2 for pi over 6, I know that I'm going to take 6, subtract 1, which gives me my 5. Okay, so take the denominator, minus 1. When you're in the third quadrant, it's going to be the denominator plus 1. So again, if I wanted the pi over 6, and I'm in the third quadrant, I'm going to take 6, add 1, and that'll give me 7 pi over 6. When I'm in this fourth quadrant, it's a little different. You're going to take 2 times the denominator, subtract 1. So again, let's just do the same reference angle, pi over 6. I'm in the fourth quadrant, so if I say 6 times 2, that's 12. 12 minus 1, that means my angle here will be 11 pi over 6. So that kind of helps if you remember those. Really, you don't even have to worry about trying to memorize all the angles and so forth. Just again, also remember we have all students take calculus. Okay, remember that first letter tells you what is positive. So we know in the first quadrant, everything is positive. The second quadrant, sine, but also cosecant is positive. In the third quadrant, tangent and cotangent, so the reciprocals of those will always be that as well, is positive. And in the fourth quadrant, cosine and its reciprocal is secant is also positive in the fourth quadrant. So knowing those will help you to remember for each quadrant and what the signs are. That's the biggest thing. Get the first quadrant. Now what's positive and what's negative, depending on sine or cosine, and don't forget tangent. When we look at the other thing I don't want you to forget about are the quadrantal angles, or the angles that are right on the axis. So that would be your pi over 2 here, your pi, your 3 pi over 2, and your 2 pi. So these are these values here, okay? And those are the ones that you'll get pretty quick. So we're going to use this information to help us to find when we solve for trig. I'm solving for these trig equations. That'll help us to determine what the values are and so forth. Okay, so now we're going to talk about the guidelines to solving trig equations. So the first thing you always want to do is isolate. So you can isolate the trig function. It's like we do for everything that we solve, whatever we're solving for, you want to get that by itself. So then now use the unit circle. So you may want to have your unit circle out to solve for the angle. Okay, so we're looking for the angle, the radian. So let's start with this one. So solve the following equations for x over the interval 0 to 2 pi. This is your domain. See how this is a parenthesis? That means not included. So I don't want, if it lands on that, you're not going to use the, whatever lands on the 2 pi, you won't use that because it's not included. All right, so if we look at just solving this 2 times cosine x equals 1, isolate the trig function. Here's your trig function. If you need to, think of it as 2x equals 1. You would know how to solve that. You divide both sides by a 2. Same thing's going to happen here. Divide by a 2, divide by a 2. So I am left with cosine x equals 1/2. So I'm going to do a few times, I'm going to ask you a few questions as we go through this. Okay, so the first question we're going to ask ourselves, well, overall. Okay, so my question, where does cosine x equal to a positive 1/2? That's kind of important. It's got to be positive because we have positive and negative, okay? So what do we know? We know that cosine x, or cosine is positive in quadrant 1 and 4. Okay. We also know if it's a 1/2, cosine x is 1/2 at pi over 3. So now we want to ask ourselves, so we have 2 possible answers because we're in 2 quadrants. Okay, so if we think about the first quadrant, so I kind of like write this over here, x equals, and then I'll put the first quadrant so I can kind of remember which one I do the right, which one. So quadrant 1, I did say that was pi over 3. And then if I think about what's in quadrant 4, okay, so if we think about, if you don't know off the top of your head, use that little mnemonic that we did earlier, just a little bit in the video, earlier in this video. We said we use our reference angle, so this is our reference angle, pi over 3. And if it's in the 4th quadrant, we're going to take the denominator, multiply it by 2, so 3 times 2 is 6, and then subtract 1. So that will give us 5 pi over 3. And that's in quadrant 4. These are the 2 possible answers to where the angle will give us 1/2. Okay, these 2 right here. Okay. Number 2. Again, we're going to isolate this variable, which is our sine x. So we're going to subtract 3 to sine x equals -1. Okay. And then now divide by 2. So sine x equals -1/2. So again, I'm going to ask myself a couple questions. So question 1. The question I have is, and I won't do this every time, but to kind of get the idea. Where does sine x equal a -1/2? All right, so we know sine x is negative in, so sine is negative, and I just put this in quadrant, which one's 3 and 4, right? Also, sine is 1/2 or -1/2 at pi over 6. So now what are those values when we think about it? First, so if we think about which one we have, so I wrote too big, so I'm going to come up here. So for x equals, so for quadrant 3, if it's in quadrant 3, I take to the denominator the reference angle, and I add 1. So that would give us 7 pi over 6. For quadrant 4, I'll take the denominator, multiply by 2, and then subtract 1. 6 times 2 is 12. 12 minus 1 is 11. So this will be 11 pi over 6. And you see a reference angle that pi over 6 in each one of those, so you can tell that's the reference angle. Number 3. We're going to isolate that variable of the sine x. So I would subtract 2 sine x because those are like terms. I probably won't always show this every time, but I want to make sure for the beginning that you understand, just showing you it's just the same math that we always do, nothing different. Just because it's a trig function doesn't change the math, procedures and so forth. Divide by 5, divide by 5. So sine x equals 1. Okay, so where does sine equal 1? And this is where I was talking earlier about the quadrantal angles, those angles that are on the axis. So when you draw your axis, okay, on this unit circle, the radius is always 1. And I am looking where sine equals 1. So if you think about all these are those values, at pi over 2, this point here is 0, 1. And remember, you're dealing with the y because it's sine. So the only place that works is right here at pi over 2. So the question is, where does sine x equal positive 1? And that's the only one that's positive 1. So this has only one answer, pi over 2. Again, where is that value at for 1? Right here. Number 4. Okay, what we're going to do is we're going to subtract 2, from both sides. Square root of 3 tangent x equals 1. Divide by the square root of 3. Again, just treat it just like any other equation. So now we have tan x equals 1 over the square root of 3. Okay, since we're dealing with tangent, I still want to ask the questions that we do before. So where does tangent x equal a positive 1 over the square root of 3? So the first thing we want to think about, what quadrant? So tangent is positive in quadrant 1 and 3. Okay. So tangent x is 1 over the square root of 3 at what angle? Now, we can't just look at those and say, okay, we're going to look at the unit circle. We could use those too. But we know that tangent is equal to sine x over cosine x. So when you think about that, you're going to ask yourself, okay, well, how do I get the square root of 3 over here in the denominator? Well, the only way for the square root of 3 to be in the denominator is if the square root of 3 is down here. So it has to be that fraction. And so when you keep, change, flip, or cancel these two, you're going to get 1 over square root of 3. But what I want you to see is that because the square root of 3 here is the denominator, this part has to be the denominator when you set that up. And so what is this reference angle at? So this is going to be at pi over 6. So x equals, so for quadrant 1, that would be pi over 6. In quadrant 3, you're going to add 1 to the numerator. And what the denominator is, it's pi over 6. 7 pi over 6. So those are two answers. So this one you have to look at this part to help you to solve this. Okay, number 5, this page still going to do the same thing. Solve the following equations for x over the interval of 0 to 2 pi. Again, we're in radians, so our answer has to be in radians, and we're looking for angles. So one thing about this, if I'm going to sit here and solve for x like I normally do, I got to isolate the sine x. So I'm going to divide both sides by 2, and I get sine squared x equals 1. Well, whenever I had x squared equals 1, if I wanted to solve, or even if a 2, let's just say, if I wanted to solve for that I would have to take the square root of both sides. But remember, when you did that, you had to do a plus or minus. Square root of 2 would be the answer. You just can't say square root of 2. So what I want you to think about is, I'll write a little note up here. When, and I want to say you, when you introduce, and I'm just going to look at the symbol of it, when you introduce the square root into a problem, add plus or minus. Okay, so again, if you introduce the radical into the square root into the problem, add the plus or minus. If you look at number 7, you'll see that number 7 does not, you're not introducing that, it's already in there. So that's what it means. You're not going to take the square root of that, it's already there. So you don't worry about plus or minus. So let's do this square root of both sides on here. So that means sine x equals plus or minus the square root of 1/2. Now, we don't know anything looking like that, so just kind of remember some of our algebra. If you see the square root of 1/2, you can rewrite it as the square root of 1 on top, the square root of 2 on the bottom. And so the square root of 1 is 1, and a square root of 2 on the bottom. But that's not going to help me, so we're going to rationalize that. And we're going to take and multiply. Remember, that's to multiply the top and bottom to get rid of the radical by what we see. So on top, we will have square root of 2. On the bottom, square root of 2 times square root of 2 is just 2. So now I can rewrite this sine x equals plus or minus the square root of 2 over 2. So the first thing to look at is that sine is x is positive, negative in every quadrant. So all 4 quadrants have to be covered. Okay, so I know that. So, but I have to remember that at pi over 4, and I said this earlier, pi over 4, sine is always square root of 2 over 2. So I know for this one, so my first quadrant is pi over 4. The second one would be, again, 3 pi over 2, 3 pi over 4. The next one would be, 5 pi over 4. And the last one would be 7 pi over 4. Some of these have patterns that you see as you go. But anyway, don't forget second quadrant, third quadrant, fourth. You can use the little mnemonic saying the denominator 1 less. That's going to be my numerator for the second. Third is 1 more. And the fourth is 2 times the denominator and then subtract 1. So these are your possible answers, or your answers. All right, number 6. Divide both sides by 5. We get tan squared x equals 3. Take the square root of both sides, because that's a square. I need just a tan x, not a tan squared x. So I'm going to take the square root of both sides. So I will have tan x equals plus or minus the square root of 3. So again, thinking about sine and cosine, we know that tangent is sine over cosine. And we want it to be where we have the square root of 3. So if that's the case, and if that's over 1, if that makes you remember it's a fraction, that means the square root of 3 has to be in the numerator. So the only one that we have is square root of 3 over 2. And then we would have 1/2. So if I think about that, where is sine square root of 3 over 2 at? And that would be at pi over 3. Now, if I have a plus and minus, that's every quadrant. So we know that tan x solution is x equals, first quadrant's pi over 3. Second quadrant is 2 pi over 3. Third quadrant is 4 pi over 3. And the fourth quadrant is 5 pi over 3. Now again, I'm getting each of these quadrants based on just my little mnemonic. Just think about 1 less here, 1 greater, times 2, and then subtract 1. If you kind of remember that, it makes it much. Number 7, solve. Subtract 2, square root of 2, cosecant x equals 2, and then divide by the square root of 2, and then divide by the square root of 2. So cosecant x equals 2 over the square root of 2. Now, cosecant is the reciprocal of sine, right? So this is a reciprocal. So if we think of sine x, sorry. So if you think of it as a reciprocal, that means I just flip, okay? I flip them over. And so that makes it nice because then now this is sine. And if I flip this over, then this one flipped over is square root of 2 over 2. So the reciprocal, I'm able to just flip over this other side of the equation. Okay, because remember the reciprocal of cosecant is 1 over sine. So if I flip that over, it becomes sine. Flip this over, it becomes square root of 2 over 2. So now where is sine? Square root of 2 over 2, but it's positive. So sine is positive in quadrant 1 and quadrant 2. So now you have to, what angle gives you square root of 2 over 2? And it's always the pi over 4s. So pi over 4 is the reference angle for first quadrant. Second quadrant, it's going to be 1 less than that for the numerator. And so our 2 solutions is that. Okay, number 8. We have another reciprocal here. Notice though over on number 7 we were able to move things over and do and such, but we didn't have to take the square root of anything. So it wasn't as, I guess, more difficult to have to figure out this fraction down here at the end. I recommend that this one you should do the reciprocal first because you don't want to try to find the reciprocal and take the square root of that and figure out what the hell that is. It's just not fun. So we're going to change this to the reciprocal. Remember, secant is 1 over cosine, squared x. So that means if I do the reciprocal, I can flip it over, and I'm going to get cosine squared x equals, flip this fraction over, 3/4. Okay, so just to make sure we understand how the reciprocal is working, when we flip them, we say, I'm just flipping this. So when I take this sine secant x and make it 1 over cosine squared x, when I flip this over, I can flip the other side over. So technically what you're looking at is you're looking at 1 over cosine squared x, because that's what secant is. And when I flip cosine to this, I have to do the same thing to the other side. So I flip that to 3/4. And that's how I'm able to do that. So now let's find the values. Well, first we got to take the square root of both sides. So let's take the square root of both sides, and we will get cosine x equals plus or minus the square root of 3 over 4. So let's just go ahead and break that up. Square root of 3 over the square root of 4. And so we will wind up with the square root of 3 over 2. So now where is cosine x equal to plus or minus the square root of 3 over 2? Because I have a plus or minus, cosine is positive in 2 quadrants and it's negative in 2 quadrants. So it's always all 4 of them. So what is that when x equals square root of 3 over 2? So that would be at pi over 6. So x equals, the first quadrant is pi over 6. Second, subtract 1, so it's 5 pi over 6. Third quadrant, add 1, 7 pi over 6. Fourth quadrant, multiply by 2, then subtract 1. So it's 11 pi over 6. So all 4 of these are the solution. So the biggest thing is knowing that when you have, when your solution is 4 answers, 1 answer, 2 answers, depending on what the odd and even and the angle that you're at, but not the odd or even, the plus or minus. So this is your answer. Okay, let's go to, I want you to try number 9 and I'll come back and see how you do. Okay, so for number 9, you should have got 5 pi over 6 and 7 pi over 6. So we had to figure out where cosine was negative and what quadrants is 2 and 3 at the angle of pi over 6 when you have square root of 3 over 2. Okay, number 10, I'm going to stop the video and you figure it out and we'll check in a second. Okay, so I did up to that point to see my work there, and I got that tan x is equal to plus or minus 1. So I just kind of want to start the video back up so you can see that, okay, so it's sine over cosine, and I have to have the exact same value. And the only way this is going to work if the number in the numerator is the same as the denominator. And the only way that we have those type of values is at pi over 4. Because when sine of pi over 4 is equal to the square root of 2 over 2, and divided by cosine pi over 4, which is the square root of 2 over 2, which gives us a 1. So in all 4 quadrants, our reference angle is at pi over 4. So quadrant 1, excuse me, you don't have to do, I'm not going to do that every time. So x equals, sometimes it helps just to be able to figure out what that value is for the next quadrant. So this is going to be 3 pi over 4, then 5 pi over 4, and then 7 pi over 4. Okay, so I went and solved this real quick and got up to sine x equals plus or minus 1. And we did a problem earlier where we found where sine is 1. Remember that it can only happen if you're on these values. These are the only way that you're going to get those for sine and cosine, 1s and 0s. So where is sine positive 1 and where's negative 1? Well, earlier we found that this, again, here is 1. And so this down here is negative 1. And you have to think about the reason I know that because this is the sine value. So what are those two values? Well, up here we have x is pi over 2. And down here we're going to have 3 pi over 2. Okay, so I'm going to stop the video. You try the last one and come back and check. Okay, so seeing if you can do this reciprocal on your own. So just think about, hopefully you got to this point. When I got up to this point, again, I don't know what this is with just secant, so it's better to work with our reciprocals. Reciprocal secant is cosine. So when I'm able to, remember that's 1 over cosine for secant. So when I'm able to see that, I can flip this over to get cosine x, and I flip this to get the square root of 2 over 2. And so where is cosine equal to square root 2 over 2? And it's positive. So cosine is positive in quadrants 1 and quadrant 4, and we want it at x equals pi over 4. So for quadrant 1, that's just pi over 4. For quadrant 4, 4 times 2 is 8, minus 1, 7 pi over 4.